Right now, today, August 9th, 2026, there's a machine in the mountains of Chile that is photographing the entire southern sky every few nights on autopilot. And in the last few months, it has quietly found over 11,000 objects in our solar system that human beings did not know existed. Not 11, not 1,100, 11,000. 33 of them are near-Earth objects. That means 33 rocks now on record that cross paths with our planet's orbit. Rocks nobody was tracking before this year. And out past Neptune, in the dark, cold edge of the solar system, it found 380 more objects. Icy leftovers from the birth of the solar system itself, frozen in time for 4.5 billion years. This isn't science fiction. This is the Vera C. Rubin Observatory, and it just turned on. At the same time, across the solar system, the James Webb Space Telescope has been staring at Saturn. And it just cracked a mystery that professional astronomers could not solve for decades. A mystery about why Saturn's own clock appears to be broken. Why the planet seems to speed up and slow down when nothing that massive should be able to do that. Stick with me for the next few minutes, because by the end of this video, you're going to understand two of the biggest solar system stories of 2026. Stories most people haven't even heard about yet, and why the next 12 months might completely rewrite what we know about the outer planets. Let's start with the machine that started all of this, the Vera Rubin Observatory. If you've never heard of it, here's the one-sentence version. Rubin is not looking for one thing. It's photographing everything, the entire visible sky, over and over every few nights for the next 10 years. Astronomers call this the Legacy Survey of Space and Time, or LSST for short. And the idea behind it is almost stupidly simple. If you take a picture of the same patch of sky enough times, anything that moves, flickers, explodes, or appears out of nowhere gets caught on camera. Think of it like a security camera pointed at the entire universe. Rubin sits at over 2,600 meters above sea level in the Chilean Andes, and its camera is the largest digital camera ever built for astronomy, about the size of a small car, weighing roughly 3,000 kilograms. To give you a sense of scale, you would need hundreds of ultra-high-definition TVs lined up just to display one single image from this thing at full resolution. On February 24th of this year, engineers ran the first real test of Rubin's alert system. In a single night, pointed at just one patch of sky, the telescope generated 800,000 alerts. 800,000 things that had changed, appeared, or vanished compared to the last time it looked. All of that data got distributed to astronomers around the planet within about 2 minutes. That was just the test run. Now that the full 10-year survey has officially begun, Rubin is expected to produce up to 7 million alerts and around 20 terabytes of new data every single night. Every night. For 10 years. And in just the first month and a half of early survey operations, before the real science mission had even formally started, Rubin had already found more than 11,000 asteroids nobody had ever seen before, including those 33 near-Earth objects and 380 trans-Neptunian objects I mentioned a second ago. Here's why that number should actually make you pause. In the entire previous 200 years of human astronomy, we had documented roughly 1 million asteroids total. Scientists now expect Rubin to find another million in its first year. Alone. One machine, 1 year, matching 2 centuries of human discovery. So when people ask, what is Rubin actually for? The honest answer is, it's the most powerful solar system discovery machine ever built, and it is currently in the process of redrawing the map of everything orbiting our sun, comets we've never tracked, asteroids on collision courses we didn't know about, and crucially, objects way out near Saturn, Uranus, and Neptune that have been sitting in the dark, completely invisible to us until now. And this is where it gets personal for anyone who's ever looked up at Saturn through a backyard telescope and felt that little chill of there's so much we don't know out there, because Rubin isn't done. Scientists are calling the next data release, expected between July and September of this year, a major milestone. Every single one of those trans-Neptunian objects Rubin has found so far tells us something about how Saturn, Jupiter, Uranus, and Neptune physically moved during the early solar system, rearranging the entire disk of icy debris around them as they went. In other words, every new object Rubin finds is basically a fossil, a frozen clue about how our solar system's giant planets got where they are today. And speaking of the giant planets, while Rubin has been sweeping the skies for new objects, another telescope has been staring directly at one of them, Saturn. And what it found solves a puzzle that has bothered scientists for literal decades. That's coming up in section 2. But first, quick gut check. If a machine can find 11,000 new objects in our own solar system in under 2 months, how much do you think we're actually missing out there? Drop your guess in the comments. I'll read some of them out in a future video. Okay, Saturn. For decades, And I mean going back to the 1980s, when NASA's Voyager spacecraft first flew past it, scientists have been staring at Saturn and noticing something that genuinely did not make sense. Saturn's rotation rate seemed to change. Not by a lot, but enough to matter. Different missions, different instruments, different decades, and every time the numbers came back slightly different, as if the entire planet was speeding up and slowing down like some kind of cosmic dial. Now, if a person tells you a planet is randomly speeding up and slowing down, your first instinct should be skepticism, because that's not really how physics works for something the size of Saturn. A planet with roughly 95 times the mass of Earth does not just casually change its spin rate for no reason. So for 40 plus years, this stayed an open mystery. Not a huge headline-grabbing mystery, but the kind of nagging inconsistency that quietly frustrates planetary scientists for their entire careers. This year, using the James Webb Space Telescope, a team of researchers finally cracked it. And the answer is not that Saturn's spin was ever actually changing at all. The real explanation: Saturn's northern auroras. Yes, Saturn has auroras, just like Earth's northern lights, except bigger and stranger, are actively heating the planet's upper atmosphere. That heating creates powerful high-altitude winds. Those winds generate electrical currents, and those electrical currents loop back around and power the aurora again, creating a self-sustaining cycle that runs continuously high above the cloud tops. What scientists had been measuring this entire time wasn't the planet's actual rotation. It was this shifting, self-reinforcing weather system riding on top of the planet, throwing off the numbers. Here's the part that should genuinely impress you. To figure this out, the team needed to measure temperatures and charged particle densities in Saturn's auroral region with much greater precision than had ever been possible before. Earlier measurements from previous missions carried uncertainties of roughly 50 degrees Celsius, which sounds precise until you realize that's way too blurry to catch subtle temperature changes. Webb's observations were about 10 times more precise than that. For the first time, scientists could see localized patterns of heating and cooling in Saturn's atmosphere instead of one blurry average. They did this by tracking a specific molecule that forms naturally in Saturn's upper atmosphere and glows in a way that acts almost like a built-in thermometer. By mapping how that molecule's glow changed across different regions, the team built the most detailed temperature and particle density maps of Saturn's aurora region ever produced. So here's the headline in plain English. A 40-year mystery about a planet with over 90 Earth masses just got solved, not because the planet's actual spin was doing anything weird, but because we finally had a telescope precise enough to separate the planet from the weather system riding on top of the planet. That's the kind of discovery that doesn't always make front-page news, but it completely rewires how scientists study every gas giant going forward, including ones we haven't even sent spacecraft to yet. And Webb wasn't done with Saturn this year either. Earlier in 2026, NASA released a combined set of images from both the James Webb Space Telescope and the Hubble Space Telescope, two of humanity's most powerful observatories, looking at the exact same planet at the exact same time, but in completely different types of light. Hubble sees Saturn in visible light, the kind of light your eyes can naturally see, and it reveals subtle color variations across the planet's bands and storms. Webb sees Saturn in infrared, which means it can effectively look deeper, sensing clouds and chemicals at many different altitudes, from the deep, churning lower atmosphere all the way up to the thin, wispy outer layers. Scientists have described using both telescopes together like slicing through an onion. Each layer of light tells you something different about what's happening inside the planet. In Webb's infrared images specifically, Saturn's rings appear almost blindingly bright, because they're made of highly reflective water ice, and infrared light bounces off that ice in a way visible light doesn't. You can even see structural details in the rings that differ between the two telescopes, subtle spoke-like features in the B ring, and a razor-thin, crisp appearance to the outer F ring in Webb's data that barely shows up at all in Hubble's. And this wasn't a one-off. The Hubble image used in that combined release was part of a monitoring program that has been tracking Saturn's atmosphere for more than a decade, watching how the planet's face and rings shift as Saturn slowly moves through its own version of seasons. A full orbit around the Sun takes Saturn about 29 Earth years. So it's seasons last years at a time, not months. Put all of that together, and here's where we are on August 9th, 2026. We have one observatory quietly cataloging tens of thousands of new solar system objects that were previously completely unknown to us, and we have another observatory, actually two working together, solving decades-old mysteries about one of the most recognizable planets in our sky. And neither of these stories required any fake urgency. No 3 minutes ago, no mystery object, just real telescopes doing exactly what they were built to do and turning up results that are genuinely stranger and more interesting than most manufactured headlines. So what happens next? That's where things get really interesting. because both of these projects are just getting started. Let's talk about what's actually coming next, because if you thought 11,000 new objects in 6 weeks was a lot, Rubin is just warming up. The Vera Rubin Observatory's full 10-year survey only just officially began this summer after a longer than expected commissioning period. Rubin's own project lead described the delay as necessary, a careful, methodical review of the system's technical readiness before switching into full science mode. That's a very deliberate, very scientific way of saying they wanted to be absolutely sure the machine was ready before letting it loose on the entire sky for a decade straight. Now that it has started, the numbers get almost hard to comprehend. Rubin is designed to revisit each point in the southern sky roughly 800 times over the full 10 years of its survey. Every single night, it's expected to capture around 1,000 images and generate roughly 10 terabytes of raw data. Multiply that out across a full decade. You start to understand why scientists keep calling this the greatest cosmic movie ever made. Because that's genuinely what it is. A time lapse of the entire visible universe, updated every few nights for 10 straight years. And the next major checkpoint is coming very soon. Scientists have scheduled something called Data Preview 2 for release sometime between July and September of this year, meaning it could land any week now. When it does, expect another wave of headlines about new asteroids, new comets, maybe even new moons around outer planets we thought we already knew everything about. Here's a detail that should stick with you. Alongside all the new object discoveries, Rubin's early data has already corrected a real measurable error in existing asteroid catalogs, a small but consistent positional bias, somewhere between 20 and 40 milliseconds that had been baked into planetary defense, tracking systems used to monitor potentially hazardous objects. In plain language, Rubin didn't just find new stuff, it also proved that some of what we already knew about asteroid positions was slightly quietly wrong. And it's already helping fix that. That matters, because those catalogs are literally part of how we track objects that could someday threaten Earth. So this isn't just about counting new space rocks for fun. This is about improving the actual safety systems that monitor near-Earth objects. Meanwhile, on the James Webb side, the story is just as far from over. Webb wasn't built to look at Saturn once and move on. It's a multi-decade mission, and Saturn is one of the objects it keeps coming back to, because every return visit catches the planet in a different part of its multi-year seasonal cycle. Remember, Saturn takes about 29 Earth years to complete one trip around the Sun, which means its seasons last year's, not months the way ours do. Right now, Saturn is transitioning out of its northern summer and heading toward an equinox, and scientists have already said that as the planet moves into southern spring, and eventually southern summer sometime in the 2030s, both Hubble and Webb will get progressively better. Views of the planet's southern hemisphere, a part of Saturn, we simply have not been able to study this closely before. That means the aurora and wind discovery I described in Section 2 isn't a case-closed story. It's closer to a Chapter 1 story. Now that scientists know Saturn's apparent spin changes were actually caused by this self-sustaining aurora wind current loop, the obvious next question is, does the same thing happen on the other gas giants? Jupiter has its own massive auroras. So do Uranus and Neptune. If similar wind and current loops are happening on those planets too, it could mean that some of the weird rotation and weather measurements scientists have puzzled over for decades on other worlds have the exact same underlying explanation. That's the real headline hiding inside this story. Not Saturn's mystery solved, but we might have just found the key to understanding weather and auroras on every gas giant in the solar system. And here's where these two stories, Rubin's flood of new discoveries and Webb's precision science on individual planets, actually connect. Rubin is a wide net machine. It's built to scan huge areas of sky quickly and flag anything unusual. New objects, sudden brightness changes, things that move. Webb is the opposite. It's a precision instrument built to stare intensely at one specific target and pull out incredibly fine detail. In practice, that means Rubin is going to keep finding new, unexplained things out near Saturn, Uranus, and Neptune. Comets, trans-Neptunian objects, maybe things we don't even have a name for yet. And Webb is going to be one of the primary tools scientists use to zoom in afterward and figure out exactly what those things are. That's the actual real-world version of something moving behind Saturn. Not a single dramatic 3 minutes ago event, but an ongoing 10-year partnership between a wide-field survey machine and a precision space telescope, systematically working through everything orbiting out there that we've never seen before. And on top of all of that, there's a broader point worth sitting with for a second. We are living through a period where two of the most powerful tools in the history of astronomy, our real-time all-sky survey and the most advanced space telescope ever launched, are operating simultaneously, pointed at the same region of the solar system. That has genuinely never happened before at this level of capability. Every year from here forward, expect this pace of discovery to continue and probably accelerate. So let's bring this all the way back around. Today is August 9th, 2026. Right now, as you're watching this, the Vera Rubin Observatory is sitting on a mountaintop in Chile, quietly photographing the sky. And it has already added more newly discovered solar system objects in a matter of weeks than most of human history combined. 33 of those are near-Earth objects, rocks that cross our planet's path that nobody was tracking before this year. 380 more are trans-Neptunian objects, frozen relics from the birth of the solar system, holding clues about how Saturn and the other giant planets physically moved into the positions we see them in today. At the same time, the James Webb Space Telescope just closed the book on a 40-plus year mystery about Saturn's rotation, proving it was never actually the planet's spin changing at all, but a self-sustaining loop of auroras, high-altitude winds, and electrical currents, playing tricks on generations of scientists' measurements. And in doing that, Webb didn't just solve one puzzle about one planet. It may have handed astronomers the key to understanding similar weirdness on Jupiter, Uranus, and Neptune too. Neither of these stories needed to be exaggerated to be interesting. They're already wild on their own. Real telescopes, real data, real numbers. You can go look up yourself on NASA's website, ES's website, or NOIR Lab's site tonight if you want to double-check everything I just told you. And honestly, you should. That's good practice for anything you watch online, including this video. Here's what I want you to walk away with. We are not waiting for the next big space discovery. It is happening right now, on a schedule, every single night, whether or not it makes headlines. Rubin alone is expected to produce up to 7 million alerts a night once it's running at full capacity. That means us somewhere in that flood of data every single night, there's a real chance something genuinely unexpected, a new comet, an interstellar visitor passing through an object on a concerning trajectory, gets caught on camera within minutes of appearing, not because of clickbait, because that's literally what the machine was built to do. And with Data Preview 2 expected sometime between July and September of this year, we could be looking at a new wave of headlines about outer solar system discoveries any week now. If you want to actually be ahead of that news instead of hearing about it secondhand, I genuinely recommend following NOIR Lab, NASA's science site, or the Rubin Observatory's own public updates directly. I'll be covering the big ones here too, but there's something satisfying about seeing the raw announcement before anyone else has turned it into a headline. So here's my question for you, and I actually want you to answer this one in the comments, not just scroll past it. Knowing that Rubin is about to flag millions of moving objects a night, and Webb is standing by ready to zoom in on the interesting ones, what do you think we're going to find first? A new moon around Saturn or Uranus that's been hiding in plain sight this entire time? A comet on a trajectory nobody's plotted yet? Or something we genuinely don't have a name for yet? Something that doesn't fit any existing category? Type your guess below. I mean it. I'm going to go through the comments on this one, and if enough of you want it, I'll do a follow-up video walking through the most interesting predictions once Data Preview 2 actually drops. If this video helped you understand what's actually happening out there, not the exaggerated version, the real version, do me a favor and hit like, because it genuinely helps this kind of content reach more people instead of the manufactured breaking news clickbait that floods this topic. And if you want to catch the next real update the moment it happens, whether that's Rubin's next data release or Webb's next Saturn observation, subscribe and turn on notifications, because I promise you, at the pace these two projects are moving, there's going to be a next one, and probably sooner than you'd expect. Today is August 9th, 2026. Somewhere in Chile, right now, a camera the size of a small car is taking another picture of the sky. And somewhere above all of us, a space telescope is quietly staring at Saturn, waiting for its next chance to look a little closer. We'll be watching. See you in the next one.